Welcome back to educator.com. For the next lesson, we're going to go over two events that are disjoint. So, two events are disjoint when those two events cannot occur at the same time. It can't happen. It's not possible. So, if we have two events, A and B, then the probability or the chance that both are going to occur is 0. That means there's no chance for them to occur together. So, it's as if I look at my two events, event A occurring, let's say it's that right there, and event B occurring would be like that. They don't overlap, so that means they cannot happen together. They cannot occur at the same time. Now, an example of this, if I were to say that right now it is 5 o'clock p.m. It is 5 p.m. So let's say this is A, event A. Then event B, if I say it is early in the morning. Well, see how event A, the statement here, it is 5 p.m., and the statement B, it is early in the morning, they cannot occur at the same time, right? It's not possible for it to be 5 p.m. and for it to be early in the morning. So these two events would be disjoint. These are considered disjoint events because they cannot occur at the same time. They cannot occur together. Now, if I were to say the same statement here, it is 5 o'clock p.m. And then for my second event, my second statement, I'm going to say it is dinner time. Well, this is possible, right? You can have dinner at 3 or 5 o'clock p.m. So in this case, probability of A and B would be not disjoint because this can occur at the same time, right? So it's not disjoint. So if two events cannot occur at the same time, they are disjoint. And if they can, then it's not disjoint. So determine if each pair of events is disjoint or not disjoint. The first one, statement A. Samantha is more than 10 years old. Okay, that means she could be 11, 12 years old, 13, 20, 30. She's older than 10. Then statement B, Samantha is less than 8 years old. Well, she can't be older than 10 and less than 8, right? So this is not possible. This would be disjoint. The second one, so the first statement, John is 6 feet tall. And then for B, John is between 5'10" and 6'2". So this is possible, right? 6 feet is between 5'10" and 6'2", right? So this is not disjoint. The next example, a box weighs 10 pounds. Name a pair of events that would make this statement disjoint and another pair that is not disjoint. Okay, so we're going to create our own disjoint events and then another pair of events that would be not disjoint. That makes sense. That could occur, right? So the first statement, the one that's disjoint, I can say, let's make it that statement right there. So A, my first one. A box weighs 10 pounds. And then for B, our second statement, to make it disjoint, a box, the same box, weighs less than 8 pounds. Okay, it wouldn't make sense, right? So this is disjoint. For not disjoint, can say, my first statement, a box weighs more than 9 pounds. And then for my next statement, a box weighs less than 11 pounds. Okay, this is true, right? These two statements are true, so it is not disjoint. The third example here, determine if each pair of events is independent, dependent, or disjoint. Now remember, independent events, when we have two events that do not affect each other. So the outcome of the second event is not affected or does not depend on the first event. Okay, dependent events are the opposite. The second event is affected by the first event. Okay, the second event, the probability of the second event occurring is affected or is determined by the outcome of the first event. And then disjoint, remember, is when we have two events that cannot occur at the same time. It's not possible for them. Okay, so the first statement, a person picks a card from a deck of playing cards. Without replacing it, another person picks another card from the same deck. So there are 52 cards, right, in a deck. A person picks a card. That's the first event. So the first pick is the first event. Without replacing it, another person picks another card from the same deck. Now, for the first event, when you pick a card, it's one card out of a total of 52, right? So this is the first event. Then, for the second event, for the second pick, since the card is not, the first card is not replaced back into the deck, there's one card missing now, right? So there's no longer 52 cards. The second person is going to pick one card out of a total of 51. Okay, so one card out of 52 times one card out of 51. Now, here, all we want to know is if the two events together, is it independent, dependent, or disjoint? See how the second event here is affected by this first event because the card was not replaced, right? It's not put back in, so now there's less cards. So the card that the second person picks might be different. It's affected. So this would be a dependent event. Okay, these are dependent events. Now the second one. Sarah received 100% on her Chapter 5 math test. Sarah failed her Chapter 5 math test. The first event is that she received 100%. Okay? She got an A+. Nothing wrong. Then the second event, Sarah failed her Chapter 5 math test. Now, if you get 100%, is that failing? No, right? So this event here with this event B here cannot occur at the same time, right? It's not possible for both to be true. So this would be an example of disjoint events. And the third one, Susan rolled a number cube and got a 4. She rolled again and got a 3. Now a number cube is a die, right? And we know that there are 6 sides. Each side has a different number. So 1, 2, 3. She rolled a number cube and got a 4. Well, what's the probability of rolling a 4? Desired outcome, how many sides on this number cube is a 4? Only one side, right? So that's 1 out of a total of 6 sides. So the probability of rolling a 4 is 1 over 6. That's the first event. She rolled again and got a 3. Well, what's the probability of rolling a 3? How many sides has a 3? Only one side out of 6. So here, to find the probability of rolling a 4 and then a 3 for those two events is 1 over 6 times 1 over 6. Now see how, even though she rolled the first time, got a 4, she rolled again, right? For the second event, rolling a 3, was that affected by what she got from the first roll? No, right? Just because she rolled a 4 the first time doesn't mean that she can't roll a 4 again on the second time, right? On the second roll. So these two events are independent. This second roll, the second event, is not affected, does not depend on this roll here, the probability of getting the 4. Okay, and that is it for this lesson. Thank you for watching educator.com.